Logarithms. Just a reminder that logarithms are inverses of exponentials. So if you look here in these two graphs that we see, they are looking at the exponential, which is in blue, and you have the log, which is in red. And they are symmetrical. Remember, inverses are symmetrical about this line of symmetry, y equals x. Same thing over here. Again, they are symmetrical about that line. So moving on, logarithmic functions have vertical asymptotes. Now, just like exponential has horizontal asymptotes, these will have vertical asymptotes, which affect the domain. So remember, vertical lines are written in the form x equals and then some number. So we want to write them as equations of lines. So for number 1, let me move this down a little bit. Number 1, find the vertical asymptote of each one. Now the key here to know is that whatever you're taking the log of, so x minus 4 in this case, cannot equal 0. You can't take the log of something and have 0. So we essentially want to know what value of x will make inside the log 0. So, well, this one's pretty simple to see. It would be 4. So x equals 4 is the vertical asymptote. Okay. So for number 2, fairly similar, but if you're having trouble, you can just say, well, 5x minus 2 equals 0. Again, you're trying to find what value of x makes the 0. So when you solve this, you get, let's see, 5 halves. So that would be your vertical asymptote. Go ahead and try 3 and 4 and see if you can get your vertical asymptotes. So the two answers here for number 3, the vertical asymptote would be x equals negative 2. And in number 4, the vertical asymptote would be x equals 3/5. Okay, to graph these, the first thing I'm going to do is find the vertical asymptote. So for the first one in number 5, we just have an x. So this one's fairly similar or simple. It would just be x equals 0. That's what would make x 0. Now to find the x-intercepts and to find my other values, I'm going to go ahead and switch it from log to exponential. So here we have our log, and then I'm going to rewrite it as 3 to the y equals x. So that way I have an exponential, and it's a little bit easier to solve with the exponential. We'll see here in just a second. So to find the x-intercept, you're going to make y 0. So it'll be some number, comma 0. This one's a little bit easier because if you look back up here in your exponential, what we just switched it, it would be 3 to the 0 equals your x value. Well, 3 to the 0 is just 1. So your x-intercept would just be 0, 1. I'm going to go ahead and draw that vertical asymptote. That's just the y-axis. So x equals 0, your vertical asymptote. And then I'm going to go ahead and plot that x-intercept of 0, 1, or 1, 0. Now you can pick, I personally think it's easier to pick values for y, because we're going to do 3 to the y, so I think it's easier to do it that way. So the first thing I'm going to do is I'm going to pick a value of y as negative 1. So 3 to the negative first will equal our x value. Again, I'm using this exponential form. Well, 3 to the negative first is 1/3. So that one's done. So I'm going to pick another value. We already picked 0, so let's pick 1 for the y value. So it'll be 3 to the first equals your x value, which is just 3. And then, why not, let's go ahead and pick 2. So 3 to the second equals your x value, which is 9. So we're going to go ahead and try our best to plot these. So you have 1/3 and negative 1, 3, 1, and I don't think I'll be able to get to 9, but let's give it a try. 1, 2, 3, 4, 5, 6. Yeah, it's pretty far out there, so I'm just going to go ahead and sketch in what this logarithm would look like. So now that we have it graphed, we can go ahead and do the domain and the range. The domain in this one would be 0 to infinity because, we can't touch that vertical asymptote. And the range, negative infinity to infinity. Go ahead and follow what we did in number 5 and try number 6. It's pretty similar, except the base is slightly different. But again, you want to follow the same steps. So for this one, again, I came up with the same vertical asymptote as in number 5, so x equals 0, because it was just log base 4 of x. So the only way that x will be 0 is if it's actually 0. X-intercept, again, was 1, 0. Again, I converted that, if you look up here, to exponential form to help me out. And I did that little work over here off to the right. And then again, I've plugged in actually the exact same numbers that I plugged in number 5. I did get different x values, so the plot is a little bit different. It's a little bit sharper. And the next one, number 7, we're going to work together, and then you'll do number 8 and see how you did. So our x-intercept, or our vertical asymptote, again, we're looking at what value of x will make whatever we're taking the log of 0. So what plus 3 will give me 0? That's negative 3. So x equals negative 3 is my vertical asymptote. So if you wanted to, you can go ahead and plot that. So that's our vertical asymptote. And I'm going to in order to rewrite this, I need to have the plus 1 on the other side first. So it'll be y minus 1, remember we have to move it to the other side, equals log base 2 of x plus 3. And then we're going to go ahead and rewrite it now. So the base is 2, and then this one, the exponent will be y minus 1 equals x plus 3. And then just to make it a little bit easier, I'm going to subtract 3 so that I can have x by itself. So y minus 1 minus 3 is equal to the x value. So that'll be a little bit easier to find our x-intercept. So if I make y 0, you're going to have, let me do that work up here, you'll have 2 to the negative first minus 3. Well, remember 2 to the negative first is 1/2 minus 3. When you do that subtraction, you're going to get negative 2.5, and then our y value is 0. Okay, so let's go ahead and plot that. It's negative 2.5, 0. That's our x-intercept, and we're going to pick some values of y. So let's go ahead and pick the number 1. 1 seems to be a nice number. So again, we're going to substitute it into this equation right here, the transformed exponential. So it'll be 1 as our exponent, so 1 minus 1. 1 minus 1 is 0, so it'll be 2 to the 0 minus 3. So 1 minus 3 is negative 2. So then our next one, let's go ahead and pick 2. So in our exponent, it will be 2 minus 1, which is 1, minus 3. So 2 minus 3 is negative 1. And then let's go ahead and do 3 while we're at it. So 3 minus 1 is 2. So we'll have 2 to the second minus 3. So that's 4 minus 3, which is 1. So we have some ordered pairs here. So we have negative 2, 1, negative 1, 2, and then 1, 3. So then we can draw in our logarithmic function there and pick out our domain and our range. So our domain in this one would be negative 3, not including negative 3, so we use a parenthesis, to infinity, and the range negative infinity to infinity. So go ahead and try number 8. You want to follow pretty much the same steps that we did in number 7 and see if you have the right answer. So for this one, I ended up with x equals 2 as the vertical asymptote, and the x-intercept turned out to be 2 and 1/27th, which was really hard for me to estimate with my stylus. So hopefully you were a little closer to the asymptote than me. The domain from 2 to infinity, and the range negative infinity to infinity. And the y values I chose 2, 3, and 4, and their corresponding x values are in the table below.